Hello and welcome. Today we're introducing two new products for mainstream 11N deployments. The 11N standard was finally ratified earlier this year in 2010. Since then we've seen a dramatic shift in people's buying strategy with a big emphasis on 11N over ABG. And by next year, 2011, we expect that at least 50% of the sales volume in units will be 11N. Of course, education is one of the biggest adopters for 11N, and historically both education and healthcare have accounted for about 50% of the total market. And since these were both the early adopters of ABG, these two verticals are in refresh cycles already, and so they are the ones that most immediately see the benefits of switching to 11N. They're already at the point where they have good coverage across most of the campus, and they are now starting to roll out 11N to replace ABG and accomplish much higher capacities in the same footprint, or in some cases expand to new areas. A great example of this is Kane University, who have recently deployed several all-wireless buildings using 11N, and as well have something like 70 MP632s outside, providing total coverage across their 120-acre campus, both indoors and outdoors, using 11N. So the first product I'd like to introduce is the MX800R. This is the brother or the sister of the MX2800, which has a 28 gigabit backplane. This has an 8 gigabit backplane and is designed for large numbers of 11N APs, even when those APs are configured to do all their forwarding through the controller itself, instead of using distributed forwarding. So this is a fourth generation controller, and we've developed some special silicon to deal with the CAP/WAP processing. So it's more powerful. It has 8 gig of line rate switching capacity for Wi-Fi traffic. Consequently, it's capable of supporting 128 3-stream APs. So even though we only have 2-stream APs, this is a 3-stream ready platform. So it's designed to scale, and it's designed to handle very high loads even in a centralized configuration. So does this undermine what we've been saying in the past about being able to support 11N with existing controllers? No, not at all. What this is doing is adding massive scalability for those users who want to have a lot of 11N and don't necessarily want to use a distributed configuration for the forwarding. Let's look at the controller family lineup. Right in the middle here is where the MX800 comes in, and eventually it's going to replace the MX200 and 216 because it has the same general capacity, but it can handle centralized 11N APs in much higher volume. So you can see the MX200 can handle 192 APs, but only if they're in a distributed configuration. So this adds a lot more scalability and also gives customers a much longer lasting platform as they migrate to 11N with 2 streams today and then 3-stream and 4-stream in the future. So everything we said about our controllers with distributed switching when it was ABG transitioning to 11N, that same story applies today with 11N 2-stream migrating in future to 3-stream and 4-stream. These controllers will give people the headroom to be able to deploy everything in a centralized model now, and then later on, if they need more capacity, to go to a distributed implementation. This is a pretty powerful box when you compare it to some of our competitors, and of course it takes advantage of everything that we've done to do with hitless failover and controller clustering for reliability. So Cisco recently announced a new product called the 5508, which is a new platform, but it's It's a general CPU, not hardware-based Wi-Fi packet processing. So it's obviously much slower and will not scale to the same extent as the 800R. The MX800 becomes available in August and is priced at $6,995 US list. And just like all the other controllers, it has upgrade licenses, in this case in 16 or 32 AP increments. And of course it also supports the high availability and advanced voice modules. Now let's look at the NP522, which is our latest 11N AP designed for mainstream deployment. As you know, 11N offers around 6 times the theoretical speed of ABG, but in practice, because of the way it works, it actually results in around 10 times better throughput. This is around a 7 times better price performance over ABG. We've priced the NP522 very aggressively to encourage mainstream adoption of 11N. In fact, the pricing is now in line with previous ABG products like the NP422. And the result is that overall, people are getting a 7 times better price performance over ABG. So this is really a no-brainer that people should be deploying 11N, even if they already have a lot of ABG and they still haven't finished completing the rollout. Now is a time for them to switch their buying strategy to 11N because they're just getting so much better value for money. This is a 2x2 MIMO platform, and we talked about the importance of 2x2 versus 2x3 or 3x3 last year when we introduced the NP82, and all of those arguments about how to deploy 11N in high density applications still hold true. You don't need the additional range that you get with 3x3 MIMO when you're deploying in high density. So just like the NP82, this has been designed to have very good power management when you throttle down the power in high density deployments. Unlike some vendors' alternatives, such as Maru, who do not fully support all the DFS3 channels, we have full support for DFS3 worldwide, and in future we'll be able to exploit the new spectrum analysis features that are inherent in the chipset that's used in this platform. So because this uses 2x2 MIMO, we can have full operation of both radios at 300 megabit rates using existing powering infrastructure with the 802.3 AF BOE injectors or switch ports. And of course it comes with backwards compatible mounting brackets so that it's an easy swap out for any 3 series or 4 series ABG access point that's already in place. The latest 2-stream Wi-Fi chipset from Atheros has new features in it for spectrum analysis. Essentially, in the past, we've had about 40 different types of signatures that we can detect to detect things like rogue APs, neighboring networks, and so on and so forth. And what's happened is that set of features has been extended with about 10 more signatures for different types of potential interfering devices that are using the same unlicensed spectrum. So that's things like microwaves, cordless phones, Bluetooth, radar, etc. So you're starting to see already vendors like Cisco and Aruba trying to make much more of this than it really is. You know, the spectrum analysis has been around for a long time, and we've been doing it all this time to detect things like rogue APs. What's interesting about this new spectrum analysis is that it's going to allow, in future, much more sophisticated methodologies for avoiding potential interference sources and tuning the network kind of dynamically and giving people good feedback as to where these sources of interference are. But it's not going to come overnight. This is a journey, and it's going to require tight integration with network management and mobility services for it to be of real value. And that's certainly the direction that we intend to go in as we start rolling out new capabilities like mobility services in the future. So companies like Cisco and Aruba are trying to make more of this than it really is at the moment. There's still a lot of work to be done for more sensitive spectrum analysis to be of real value. No one really needs another point product in this area because wireless is complicated enough without trying to look at the RF spectrum of a single radio, one radio at a time. It's not very useful. It needs to be much more holistic. So before you get sucked into trying to defend why we don't have a spectrum analyzer product, get your customers to ask vendors for their spectrum analysis roadmap and mobility services SLA roadmap, because this is where they're going to come unstuck, and we're going to have a pretty good story to address that. You'll remember back in 2009 when we launched the MP82, we introduced this notion that when you're deploying for maximum coverage, you need to have a different strategy than when you're deploying for maximum capacity. This AP is targeted at the maximum capacity scenario. And that's why it doesn't have 3x3 MIMO. You only need 2x2 MIMO or 2x3 MIMO to get the real value of 11N when you're deploying in high density. When you have 3x3 MIMO, that's helping you get much better range. But in high density deployments, that range doesn't buy you anything, because what you're normally doing is turning down the transmit power and shutting off outlying data rates. So the added cost of 3x3 MIMO brings you no value. This is why the whole industry is following the path that we blazed last year. There are two versions of the MP522. There's one version that has internal antenna ports, and that's what I've just talked about. But there's also another version with no internal antennas and only external antenna ports. And this is designed to address 5 common indoor-outdoor applications where people may not want to spend the kind of money involved in a full 3x3 outdoor AP like the MP632. A common application is in use with distributed antenna systems, which are very popular in hospitals. Many vendors have had problems with DAS systems because the APs need to be put in the wiring closet right next to each other. And the trouble is that when you have internal antennas, you can't completely turn them off when you're connecting to the distributed antenna system, so you end up with a lot of interference in the wiring closet. This eliminates that problem completely. Another application is having hybrid indoor-outdoor deployment where you have the AP mounted inside and the antennas mounted outside on the wall, so that you're providing client access to people that are outside the building. Another common application is point-to-point bridging or multi-point bridging between buildings. So you may have a couple of adjacent buildings, you don't want to run fiber between them, but you can use very low-cost Wi-Fi bridging between these two buildings with an antenna stuck outside of the building at each premises and the AP, again, inside the building. In a similar fashion, this can be used as an outdoor mesh portal, again, mounted on the interior of the building with the antennas on the outside of the building. And finally, anywhere where you can provide low-cost PoE and a climate-controlled enclosure, this is a nice low-cost outdoor AP solution. The MP522E comes with 4 paddle antennas as standard. These are omnidirectional, 360-degree antennas that are mounted on the AP itself. You can take these off and then replace them with any one of these 4 alternatives, which are either 360 or sector antennas, and all of these antennas will be homologated over the coming months. There's a good reason why we've come up with 2 separate products instead of trying to have one product with internal and external antennas. One of the reasons I mentioned earlier, and that is that when you have internal antennas, it's very difficult to completely switch them off and isolate them when you have external antennas. So you lose power and you have interference leaking through between the internal and external antennas. As we start moving into much more mainstream deployment of 11N, price is becoming a much more important factor. And we don't want to burden the 95% of the units which are going to be used indoors with the excess cost to support external antennas. So for only 5% of demand, you don't want to be burdening 95% of your product. So this allows us to meet the price point that our customers need and gives us the flexibility to address a variety of different indoor and outdoor applications. Again, using US pricing, this is how the indoor and outdoor AP families line up. So on the indoor side, you can see there's a very small delta between the MP422 and the MP522. And then in outdoor applications, you can see that there's a really big delta between the full 3x3 MIMO MP632 bulletproof, industrial grade, completely environmentally hardened platform, and the MP522E, which is a low budget solution. Obviously, you'd have to add some additional things like the climate controlled box and so on, but there's a big delta there. So if your requirement does not require industrial grade, environmentally hardened equipment, and most of your outdoor requirements are in closed quarters, and it's possible to mount the AP indoors, then the MP522 is a very attractive solution. As you know, we also have the MP82, which came out last year and is a 2x3 MIMO product, which also fits in this family. So when should you sell the MP82 versus the MP522? There are some customers to whom you've already been selling the MP82, so it makes sense you should continue to offer them the same product. 2x3 MIMO offers slightly better receive sensitivity, which improves the range, but otherwise these platforms are virtually identical in terms of functionality. If they need plenum rating, then they should use the MP522E, which is suitable for plenum applications. The MP522, on the other hand, is the best fit for any Nortel or Trapeze or even Enterasys ABG to 11N upgrades, and it's also the preferred solution for any new greenfield 11N deployments. When should you sell the MP522E instead of the 632? So the MP522 is ideal for low budget requirements, especially when the AP can be mounted indoors. But for really hardcore permanent fixtures where the AP has to be outside, especially in any harsh conditions, windy, hot, cold, salty, dusty, the MP632 is the ideal platform for these applications. So as you can see, the MP522 and MP82 are virtually identical. The only real differences are the smoke detector-like form factor and the plenum rating on the MP522E. So that's a summary of the new product introductions for mainstream 11N deployment. For more information, please look at the datasheets and training materials. That's it. Thanks for listening.